Hey Dev Team, welcome back to Flutter with Drag. Today I'm going to make Wordle in Flutter. If you're not familiar with Wordle, I'll just shove an image onto the screen here. It's a word game that has taken a lot of the world by storm, just been bought by New York Times. And essentially it's a guessing game with logic and deduction. So you start off by guessing a word, a 5-letter word, and when you submit that guess, the game tells you via the use of colours whether the letters in your word are in the word that it has chosen, the answer word, and it also specifies whether it's in the right position or not by using a different colour. If you've not played it, just do a quick Google, you'll find it and have a go and you'll see what it's all about. However, we're going to try and do this fairly quickly. I'm going to try and do this in just this one video. It's not going to be a series. And it's not going to be complete by any stretch of the imagination. It's going to be fairly bare bones, but we'll try and get as much of the gameplay into it and the logic as possible. Okay, to do this I'm going to be using the Bloc pattern again, so I have already installed, where is it, Equatable and Flutter Bloc. And I've created a new project obviously for this, which I have called Flutter Wordle. So Equatable and Bloc, and I'm using VS Code, and within VS Code I'm going to be using this extension by Felix Engelov called Bloc. So you'll need that installed to follow along. So I've done those, I've got our app running, it works, we're ready to start coding. So first things first, I'm just going to delete my app and start from scratch. So let's create that again. Stateless widget my app. That's going to return a material app. We're going to set show not that one. Show checked banner to false. We're going to have a home, and the home is going to be a scaffold, and the scaffold is going to have an app bar, and the app bar is going to have a title, and the title is going to be a text widget, which we'll just call Flutter Wordle. Okay, let's save that for a second. Just check we've got everything working. We have. Going to put a comma there. I'm going to center the title just to make it look a little bit better, and change this to a constant because that's never going to change. Okay, step 1 done. Step 2 then is to, within our scaffold, build the body, and I'm going to put a column in, but I'm going to put it into a sized box expand to make sure that it has some sizing information, and we'll put a column. The column is going to have 2 children, container first of all. Now this is just a holding container, this is where our grid is going to go, so let's just set this to a width of 300 and a height of 400, and give it a color, colors.red. How does that look? Might be a bit too big. Let's change the height to 350. Excellent. And underneath our grid we're going to have a keyboard, which I am going to call keyboard. Now that doesn't exist, so let's come straight down below and create another stateless widget called keyboard. And the keyboard itself, if we look at our Wordle image or our keyboard in front of us, we're just worried about the letter keys. So we have 3 rows with a load of things in it. So let's put in a column. So we've got 3 rows in a column. And the children for that is going to be a row, followed by a row, followed by a row. Now the rows are going to contain keys, and each of the keys are going to have functions and things attached to it. So instead of repeating that lots of times, I'm going to come down below that again and make another stateless widget called, I was going to call it key, but can't call it key because there's already a widget called key and things we're going to need. So let's call it keyboard key. Yeah. Now the keyboard key is going to take a final string letter. We need to know what key it is, and that's going to be required because without that, key won't know what it is or how it works. Let's put one of those in our row now, in our top row. So keyboard key letter, and we'll just choose the first letter on the keyboard, which is Q. So we know what it looks like. So within our keyboard key, we certainly want to display that. So we'll display the text letter. All right, let's save and see what we've got. We have a Q. Wonderful. Let's make that look a bit more like a keyboard key. So let's put a decoration on it. And the decoration is going to be a box decoration. And I think we'll set the color to be colors gray and 350. We'll make it a little bit of a lighter gray. Okay, that looks okay. We probably want to have a width. Whoa, not like that. Because it doesn't go in the decoration. Outside the decoration, we want a width. Let's say 30 and a height of 45. It's a bit taller. Yeah, that's probably all right. We might have to adjust that later. Certainly want an alignment, and we want to align our thing to the center. And if you're wondering how I type that quickly, if you're not familiar with VS Code, you just need to type parts of the word. So align, and then I started typing center. So well, I've got Alice there, but the first part's from align and center. And as you can see, it's highlighted the alignment center for us, just hitting enter. Just a shortcut if you're not familiar with that. Within our box decoration then, let's just put on a border radius. Always makes, border radius, that always makes boxes look a little bit better. And again, we're going to do a border radius circular. So I type BOR-CIR, and we've got border radius circular selected for us. And then just pop in 3, I think, into there. I don't want much of a radius. All right, that'll do for now. We'll come back later. So what we need to do is put all our keys in to our rows. So the quickest way of doing that, let's think, would be to type each of the letters out. But if we do that, I suspect I'm going to end up, so at the moment I'm typing each letter followed by enter, and I've got a right old mess because of auto completion. So let's just undo all of that. And what I'm going to do is I'm just going to type all the letters in one line. So I'm just going across my keyboard, across all the lines to get all the letters. and then I'm just going to come and hit enter, right arrow, enter, right arrow, all the way along to get all the letters. Just fits on the screen. And then using my middle mouse button, I'm going to select before the W and drag down to before the M, which gives me multi-cursors. And now I can type in keyboard key, open brackets, letter, just hit tab, open speech marks, hit the end button to jump to the end, close speech marks, close my bracket, put a comma on. And we now have all the keyboards. So let's head down to A, because from A down that needs to be part of, I'm going to cut those out because they're in the second row. So children, paste, and then from Z down I'm going to cut them out and put them into our final row, paste. And there we have them on our screen. Now, all these under the squiggly underlines is basically because we can turn these into consts. So we're just going to add const before children in each of the row, and that will keep our Flutter linter happy. Okay, back down to the container of the keys. We need to put a bit of spacing between them. So the easiest way of doing that is to put a margin const, no, not context, const, edge inset all 4. And that'll just put a margin of 4 around everything. Excellent. And then our rows, we need to center everything. So main access, oh dear, the autocomplete is going haywire. Main access alignment is going to be main access alignment center. And we'll just copy that into each of the rows. And that's our keyboard laid out. Now, in the final row, we want 2 more buttons. So I'm just going to copy the Z. And the way I did that was holding Alt-Shift and hitting the up arrow, and it just duplicates it. This is going to be the Enter button. And I'm just going to click on the M row, and again, Alt-Shift down to make a copy going down. And this is going to be the delete button. So I'll save those, and we've got them, and we'll prettify that up later. All right, good start. We've got our keyboard ready. This can be a const here as well. We have our keyboard ready to go, and we can now start building our grid. So in order to build our grid, I'm going to start by building our block, because we need to keep the state and the grid. So on the lib folder, I'm going to right click and I'm going to go down to block, new block. And I'm going to call this, what should we call it? A Wordle block. Am I happy with that name? Yeah, it'll do. Right, decisions. So let's come into our WordleState and let's think about what we're going to need. I'm going to get rid of this abstract here, and I'm going to get rid of this class Wordle initial. Okay, so the first thing I'm going to need is to keep track of what state the game is in. And there's going to be a few states, I think. So I'm going to put an enum and list the possible states that our playing board is going to be in. We're going to have a loading state when we first get there and we're trying to load it up. We're going to have playing state. We're going to have finished state. And I think actually we're going to have there's two finish states that could occur. You could finish and have lost the game, and you could have finished and won the game. And I'll put those separately, I think. What's this complaining about? It's complaining about we haven't given it a name. Of course it is. Quiz status, game status. Okay, I'm going to create an override for this now. Yeah, and an override, if you're not sure what an override does, it gives us the ability to add extra methods, extra properties to an object. So, for example, if you think about a number object 1, if we were to have that in a function, let's do this. Void test. Right. So if we had 1 and hit dot, we've got all these extra things we can do, such as convert it to a string, round it, convert it to a number. There's all sorts of stuff, but we can add extra stuff. So if we were to create a game status called myStatus equals, and we'll just initialize that to game status loading. And don't do this here. We're going to delete this in a second. I'm just trying to demonstrate extensions. If we type myStatus dot, you can see that we've got a couple of things, index and name. We get a hash code and a runtime type, and we can convert it to a string. Well, we're going to add, using an extensions, we're going to add some more stuff to that. So let's do it, and then you can see game status x on game status. So we're creating an extension called game status extension, and we're creating it on the game status. And we're going to return a boolean that is loading, and that is going to return this equals game status is loading. Now we've done that, if we come back down here and type in our dot, we have this is loading, which we didn't have before. And if we did that, that would return true if my status is loading, which it is by default. So this is the object it currently is, and then it's comparing it to and returning a boolean. So we want one of those for each of our states. It just makes the code look a little bit nicer as we're typing. Is finished lost, and is finished won. And we just need to make sure that we've got the right comparison over here. So is playing, is finished lost, and is finished won. And so now with my status, we have all of those available to us. And it just saves us doing things later on. So we could say, for example, if my status is finished lost, we might do something there. That's exactly the same as typing if my status equals game status finish lost. So either way works. I just think this looks a little bit neater, makes the code a bit more readable. I'm also going to make one other final one because I think I want to know if the status is finished regardless of which just realised I spelt finished wrong there. Finished. Regardless of which one of those we're in. So we can create another bool getter just called is finished, and that will return a boolean is finished lost or is finished won. So if either of those return true, that will return true. Okay, there's our game state. So let's keep track of that. So in our WordleState, we need to final game status. We'll call that status. We're also going to need a string, which is the word. So when the game starts, the app is going to have to pick a word to use as the target, and that's where we're going to store that. We're going to need to know how many guesses the users had, because they only get 6 guesses. So we're going to have an integer which we'll call guess number. That needs to be a final as well. We're going to have a string called error message, because I think at some point we're going to have to throw an error message back to the user. So we will want to store that. And then we need a list of our grid states. So thinking back to our Wordle grid, what we have is a number of boxes. We've got 30 boxes, 5 by 6, 5 columns, 6 rows. And so I'm going to call that, what should we call that? Quiz box, game box, quiz box, box. Is there a box already? No, we've got box border. We'll call it a box. So we're going to have a final list of box, which we will call our grid. Now, box doesn't exist yet. Let's come down and make it. So class box. What's the box going to need? Well, first of all, we're going to need to know the letter that's in the box. So let's do that. Final string letter. We're going to need to know the status of that letter. Was it an incorrect letter? Was it a correct letter? Was it a letter that's in the correct position? So let's call that box status. And I think that's probably all we need. So let's create our enum for our box status. And we're going to need, let's think, initially the box is going to be blank. Then the user is going to type something into it, but it's not getting checked. They're just typing it in. So that's going to be answered. They put an answer in there. Then we need to know whether it is the correct letter. Oh my gosh, correct letter. Then we'll need to know if it's a correct letter and in the correct order. So I'm just going to call that order. And then we also need to know if it's an incorrect letter. Okay, just like we did before, I'm going to create an extension for all of those. Extension box status x on box status. And again, we're going to create bool get is blank returns this equals box status blank, and we need one for answered, correct, order, and incorrect. So is answered, is correct, is order, is incorrect. Let's fill those in. And that's that. Okay. Right, we need to create our constructors now for that. So control dot generate constructor, or create structure for final field, depending on what extensions you've got installed. Essentially, you want to end up with that. And then we also want to add into this the ability to copy with. And we've done that. I think that's another VS extension, so hang on a sec, let me find that and show you what extension that is. Yeah, here we go. That's the data class generator from Bendixmar. I'm pretty sure that's the extension we're using there. So you may want to install that one as well. It's another useful extension to have in VS Code. Nothing stopping you, of course, typing it all out by hand. You just need to copy that. Okay, coming back up now to our WordleState. We need to do the same thing. So control dot and generate constructor, which will create that for us. And in fact, that's generated the wrong type for us. We want this to be named, and we want all these to be required. So let's just put that in. And we also want for this a copy with. So let's put that in for us. And then importantly, this override. This override props is part of the equatable package, and we'll make sure that when our block states are emitted, our block checks for changes, but it only checks for changes of properties that are listed here. So for example, if our status changed, the block would ignore it unless we put status in here. Well, we don't want our block to ignore anything, so we're going to put all our properties in here. Like so. Okay, that's our state pretty much taken care of. But I also want to have the ability to create an initial state. So I'm going to do that with a factory, which is going to return a WordleState, which I'm going to call initial. And that is going to return a WordleState. Let's just put that on multiple lines. There we go. And our initial state is going to be game status loading. Our initial word is going to be blank. Our initial guess number is going to be 0. Our initial error message is going to be blank because there isn't an error message. And then our grid we need to create. Now our grid is a list of boxes. So we're going to generate a list of 30 boxes, 5 by 6, of box. And let me just get this on multiple lines again, so make sure it's not hidden behind the emulator. And our initial letter in our boxes is going to be blank. And the initial box status is going to be box status blank. Okay, that is our state setup. So let's save that and come now to our Wordle block. We can probably close that down. Now we're going to get rid of this on for a moment. And our initial state, which we've got to put in, isn't going to be Wordle initial. It's going to be WordleState dot initial. That's the state we've just created. That's the factory we've just created. So we can save that. and now we can come back to our main.dart, and now we have our grid state built, albeit blank. We can now come and build it. So let's do that. Now, first of all, we need to provide the block to the whole of the app. So on Material app, I'm going to click on that and put on Wrap with Block Provider. And the block we're going to provide is the Wordle block, which we're going to need to import. And we're also going to need to import Flutter block. Okay. Then when we come down to our container here, in fact to our column, I'm trying to think where the best place to put this is. We're going to need to do it on our column. It's probably not the most efficient place, but it's going to go there for now. We're going to put a block builder, and the block builder we're going to put there again is the Wordle block. So within this builder we now have access to the state. Okay, so instead of this container we're going to use a grid view, gridview.count, because within gridview.count we can specify the number of elements, the number of widgets we want on the cross axis, and that's 5 because it's all our words have got 5 in it. This then also takes a list of children, and there I'm going to extract that out to a function called BuildGrid, and I'm actually going to pass the state into that. Okay, now coming down to within our class still, we're going to create that function BuildGrid. That's going to take a WordleState called state, and it's going to return a list of widgets. Okay, now it's stopped complaining up there. So we need to create our individual boxes now. So let's create a list of, let's have a think. Yeah, we're going to create a list of widget, which we're going to call grid, and we're going to set that to be an empty grid. And then we can say here for var box in state.grid, i.e. for every box that we've got in our grid list, which we're going to create a new variable called box, or a new reference to it called box, we are going to return a container. No, we're not. We're going to add to this. So to that grid, we're going to add, what are we going to add? Let's just try a container. And for now, we will put a border on that container. So we're going to put a decoration, box decoration, border, borders dot all, colors dot black. Nothing too fancy. And then after that for loop, we're going to return the grid. So we're returning the grid, which should now be full of 30 containers with a black border. Got an error somewhere. We're missing a comma there. Let's save that, and we'll find it's all gone a bit haywire, and that's because we need to specify a size. Grid view can't really work out the size easily for itself. The grid is going to be, if it was a square, it would be easy. If it was a square, we could just put it in wrap it in a widget, size box square, and we could put in a dimension of 300. And that would bring us back in, that would constrain it, but this gives us 5 by 5. Obviously it's a square and it's not, it's 5 by 6. So we can't do from square. So we're going to have to do from size and work out a size from size. And we can pass in a size of 200 by 300, for example, and that gives us a grid. But I want to be a little bit cleverer about it because I want the size to relate to the size of the screen. So in our builder, in fact we can do it right at the top, so this calculation doesn't have to be done time and time again. Let's create a double called width, which equals media query, not that, media query of context size dot width. Okay, I only want it to take up 60% of the width of the screen, so I'm going to multiply that by 0.6 and then divide that by 5 because we have 5 boxes, and that should give me the width of each of my boxes. So then we can create a double called size. Sorry, no, it's not a double. We need to create a size called size, which equals size width times 5, because that's how many we got. And then the height is also going to be the width, because the box is a square, times 6. But I'm going to add a little bit more to that just to make it a little bit taller than it is wider. And then here in our size box from size, we just need to pass in that size. Let's save that and see what happens and hit refresh. And of course we can't do that because we haven't got a context. So yeah, my mistake. Let's cut that out and we will have to put it in the block builder. So just paste it into there. Okay, that gives us our grid. Okay, let's put a bit of spacing in between each of them. So cross-axis spacing 8, main axis spacing also 8. Yeah, that gives us some spacing. And in our column, let's just put a sized box height 20, just knock it down a little bit like that. Perfect. That can be a const. Okay, that's our grid built. Right, let's come to our block events now and work out the events that we're going to need. So each event needs to be a class that extends the Wordle event class. So the first event that's going to happen is we're going to start the game, so we need to load the game, and that extends the Wordle event. Wordle event. Okay, so that will load the game. Then the game is in progress, and a player might, what will they do? that you might, let's copy that, enter a letter. So letter, enter letter, enter letter. Yep. They might also delete a letter if they've got one wrong. Once they've put in their word, they're going to submit the guess. And that's all that's going to happen. I'm going to put one more in, which isn't really part of Wordle because you can't actually do this, but for us and for testing and things, I'm going to put in restart quiz game. Okay. Now the only one of these that takes any sort of property is going to be enter letter, because we need to know what letter they have entered. So within the entered letter, we're going to have a final row, new event, final string letter. We're going to generate the constructor for that, which is going to be a const. And we're also going to override the props for that so that Equatable looks at it. Letter. And I think that's it. So coming to our Wordle block, we can now deal with each of those events. So on, and then the type of on. So let's get our things. We've got load game, so that's our first one. So on load game, we want to do something. So let's take our events one by one, copy and paste, copy and paste, copy and paste. Need one more, copy and paste. So that's going to be on enter letter, on delete letter, on submit guess, and on restart game. And then we just go through each of these one by one and create the method. Like so. So we have our methods where we can set everything up. Okay, let's save that. I've got an error in here somewhere. Got too many speech marks, too many curly brackets. Okay, save that. Restart that app, restart, make sure this is all loaded in, and come back to our main screen. So now we can start building, and we can start here. Before we return the column, we can say if state what did we call the state? Status. If state status is loading, return, let's put it in curly brackets, return center child circular progress indicator. So if our game is loading, which is the initial status, but that's constant because that's never going to change, we're going to return that. So let's save that. And that's right, because our status initially is loading, that's what we're going to see. And of course you could replace that with a much fancier loading screen with pictures and your logos or whatever. So let's come back to our block and do something with this onload game. And what we want to do here is we want to emit a new state. And the state we want to emit is a copy of the current state, but with a change, and one of the change is going to be the status, which is now going to be game status playing. So the loading is completed and we're playing. But in order to play, we're going to need a word that has been selected as the word we've got to guess. So for now, I'm just going to set that up as a string word, and it's going to be the word world. It's a 5-letter word, fits in with hello world. And within our state, we need to store that as well. Let's do it at the beginning. So we're going to say word is the word. So when our load game event is called, we're going to run this, and we're going to set our word to world, and we're going to copy the state, or emit the new state, which is a copy of our existing state with the new word set and the status set. So now if we come back to main and come up to where we create the block, we can add that as an event, and a quick save of that and a refresh, and with a bit of luck our game state will load up. And as you can see from the emulator, we're no longer in the loading state, we're now in the playing state. So the next thing we have to tackle is users being able to push the keyboard buttons, and those keyboard buttons doing something. So let's come down to our keyboard key and wrap that with a widget gesture detector, which will turn it into a button for us. And then we can say on tap, do something. What do we want it to do? Well, we want to go to our context and we want to read our Wordle block, and we want to add an event, and the event we want to add is enter letter, got what we called it then, enter letter, and we're going to pass the letter that is passed into this button to that state. Let's save that and come back to our event there. So as you can see, we're taking in the letter, and then in our block on enter letter we need to do something. And what is it we need to do? Well, we need to emit a new grid, but this time we need to change one of the boxes to contain that letter, and the box we need to contain is the first empty box. So I'm going to write a couple of helper methods here, or helper things, because we're going to be using this a couple of times throughout, I would imagine. First one is I'm going to create a getter which is going to return an integer, and it's going to be called first empty. And that is going to look through our state and the grids in our state, and it's going to find the index where the letter, or the box, has a letter which is empty. Okay, so for all the boxes in our grid, we're going to go through each box. We could call that box. And for every box, it's going to look at the letter. And the first one, where it finds one that is empty, it's going to return true. Yeah, So if we look at the description for index where, the first index in the list that satisfies the test. Another getter I'm going to want to make use of, I think, is the row start index, and that is going to be the index of the current row. So if you think of each row within our game grid as being a guess, we need to know which is the start of the current row we're working on, and that is going to be this guess number multiplied by 5. So the first time round our guess number is 0, we've set that at the beginning, so 0 times 5 is 0, so the first one is going to be the 0th index. Second time round our guess number is going to be 1. 1 times 5 is 5, therefore if we look at our emulator, this is box 0, 1, 2, 3, 4, 5. Third time round it's going to be 2. 2 times 5 is 10, so this is 5, 6, 7, 8, 9, 10, and so on and so forth. I also need to know the end index for the row. Row end index, and that is going to be the row start index plus 4, because we've got our start one, 4 more, 1, 2, 3, 4 is our end, and those 3 things will help us along the way. I'm going to make one more as well, just as a convenience thing, which is going to be a string get word, which is going to return current state word. Okay, not sure where Cupertino's come from. I'm going to get rid of that up there. Let's come down to our enter letter. So what do we want to do here when we enter the letter? Well, we want to find the index of the first empty. So int index equals first empty. We then want to take a copy of our grid. So we're going to make a list of our boxes called grid, and that's going to be state copy grid. This is why we did the copy grid earlier. So we now have a copy of our grid, because remember our state is immutable, we don't want to be changing it, and that gets us a fresh list, which is our grid. And from that list we want to change the box at the index, which is the first empty, and we want that to be a box with the letter being the letter that's being submitted, so the event letter, and the status box status answered. We then need to emit that state copied with our new grid. We save that and we refresh. It's still not going to quite work, but if we click some buttons we should have letters being entered into our state. But coming back to our main.dart and coming back up to our build grid, we're not displaying that. So let's make the child of the container a text which contains the box letter. Save that, we've got the letters. We can also make that a little bit nicer just by setting an alignment to alignment center. And we'll worry about formatting it, making it look better afterwards. So now as we hit our letters we can see that the next grid, or the next empty box, is being filled, but once we fill it and hit a button we're going to get an error because there's no more empty boxes. So we need to handle a few things. First of all, we want to make sure that when people are entering, when users are entering letters, they can only enter 5 at a time. They can't fill the grid like this. Coming back to our block, after we've got the index, let's put a check in here. And the check is going to be if index is less than 0 or index is greater than the row end index, return. Now return is going to give us a problem because we're saying a future or a void and we're not returning a future. If we just put async here, we're now returning a future. So index 0 less than 0, why is that? Well, our first empty index where, if we read it, it says returns -1 if element is not found. So if we're in a position where there is no empty index left, it's going to return a -1 and we're not going to do anything, i.e. if we've got to the end. Or if our index is greater than row end index. In fact, we probably don't need that, but it's belt and braces. Let's save that and refresh. And now if we put in some letters, we can't go past that first row. Fantastic. So that would be our first guess. So the next thing we can do is would click the enter button to submit it, or the delete button to delete some words, letters. Let's handle the delete button first. Coming back to our main, we've got a problem in that our delete button is just a set of strings saying del. So within our gesture detector, we need to check if one of those two special buttons have been pushed. So we can say if letters equals ent, do something, else if letter equals del, do something, else do something else. So the something else will be what we're doing already, and for the enter it will be adding the event submit guess, and if it's del we'll be adding the event delete letter. Save that, and that's those handled. So let's try delete. Well, it didn't do anything, so let's make it do something. So on delete letter, what do we want it to do? Well, the only letter it can delete is the last letter that has been entered. So let's do what we did before for the entering. In fact, we can copy this to make a new copy of our grid. Okay, and then we're going to get an index which is going to be the last letter, but we haven't got a convenient thing for that because this is the only place we're going to need to do it. So what we need to do is look through the grid and find the last index where our box.letter is not empty. So now we have the index of the last box, and then at that grid index we can make that equal to a box where the letter is blank and the status is box status blank. We can then emit that grid in a new state. So state copy with the grid being our new grid. Okay, let's save that and hit our delete button, and we can delete. And we can delete past the last letter. So we need to put the same check in that we did before. And that is if index is less than 0, return. There's nothing to delete. And we'll make this an async function to make sure future is being returned. Okay, so refreshing that, we can now put in 5 letters and we can delete 5 letters. Excellent. Now on submit, what we're going to do for now is just increment our guess number. There's going to have to be a lot more logic here, but for now we'll put InitialState copy with guess number equals state dot guess number plus 1. Oop. 2 brackets. Okay. So now we can put in 5 letters, we can hit enter, and we can put in 5 letters more, and we can delete those letters. But if I keep putting delete, we're now going to be deleting the original guess, and we can't change a guess once it's been made. So we need to take that into account. And we can do that within our top of our onDelete and say if state grid at the start of the row dot letter is not empty, allow all this to take place. So if the box at the start of the row we're currently on is not empty, then we can delete. If it is empty, i.e. if we've deleted everything on that row already, then no more deleting for us. Okay, now the reason I've done state grid here and then copied the grid is because this is slightly more expensive. We're making a copy in terms of computational, and so we don't need to make a copy of the grid if we're not going to be doing the rest of this. Let's save that and refresh, and now let's type in 5 letters. Excellent. And I'm typing more and nothing's happening. Let's delete all those, and that works. Type in another 5 and submit. And now we can type in another 5 and not go any further. Hit delete. They all go and no further, and we can type in a different 5. So that is all the logic that we need to do for entering and deleting letters. Now all we need to do to finish this off is deal with our onSubmit. Okay, let's deal with this then. And so the first thing we want to do is make sure that we've got 5 letters, because you can't submit if we haven't already got 5 letters. So we can say if state grid, and then we want to get the row end index, check the letter, and if it is empty, we're going to return. And again, I'm going to make this async so it returns the future. So that makes sure that we've got 5 letters in our row. Otherwise, there's no returning for us. Right, then we need to get a copy of the grid. Let's do that. And we need to go through every letter in the current row. So to do that, we're going to put a loop in, and we're going to create a variable index which is going to start at the row start index, and we're going to continue this loop while I is less than or equal to the row end index, and each time we go through the loop we're going to increment I. So our first time round we're going to start at 0 while it is less than 4. So 0, 1, 2, 3 and 4, that's our 5 letters. We're going to do something. And for now, we're going to do something a bit bonkers, perhaps. We're going to set the grid at I to be the grid at I copy with, because we're not changing the letter now, so we need to keep whatever letter's in there. We're just going to change the status, and for now I'm just going to change it to incorrect. So regardless of what we've typed in, everything is going to be incorrect. And then we need to omit not just our new guess number, but we also need to omit the new grid as well. Okay, let's save that and come to our emulator. And now when we hit enter, our first row has been submitted, but we're getting no visual display of that. So let's deal with that by coming back to main and coming to our grid builder here, and outside of our, or inside of our box decoration, outside of our borders all, let's set the color of that cell to be grey if it is incorrect. So we can say if box dot letter or status, sorry, if box status is incorrect, we're going to have colors dot grey. Otherwise, we'll have colors dot white. And when we save that, with a bit of luck and a bit of a refresh, when we submit our first row, they all turn grey because they're all wrong. When we enter our second row, same thing happens. Now, coming back to our box status, we're going to have multiple different colours depending on the status. So I'm going to write a little function here that is going to return a colour called getColor. That'll do. And we're going to pass into it a box status. And we're going to put here if status dot is correct, return colors dot orange. So a correct status means the letter appears within the word, but it isn't in the correct position. Else if status is order, that means that it's in the right position as well. We're going to return colors dot green. Else if status is incorrect, we're going to return colors dot grey. Else we're going to return colors dot white. Put a return in there. So getColor will return the right color for us. So instead of doing that, we can just now say getColor box status. And if we save that and refresh, we should find that still works, which it does. So now we just have to work out the states of correct and otherwise. So let's work that out. How are we going to know if we've got the correct letter? Never mind the order. Well, we can say if the word contains the grid I letter, then do something, else do something else. Now the something else is going to be wrong. so we're going to set that as incorrect. But if it does contain the letter, we're going to set it to correct. So if our word, and don't forget our word is here, is the state word, it's what's being the word we're trying to guess. So if that word contains the letter of the current grid that we're iterating through, then we're going to set it correct, otherwise incorrect. Let's try that. So we know the word is world, so let's put G, H, K and J in, because we know none of those letters should appear in the word world. Enter. Okay, now let's put in letters that should appear in the word world. O, W, L, R, D. Enter. They're orange. And if we put a mixture of them in, we get orange just on the ones that are correct. So the orange says they're correct, but they're in the wrong place. But if we put world in, we should expect this to be green. But of course we haven't put that code in yet. How do we know if that's right? Well, let's come up and we're going to say if grid I letter, so if the current letter that we're checking is the same as the word at the index 5, then copy this line, else if order. Right, let me explain that. So if the current letter is this, what is this doing? Well, this is getting the remainder of words. So let's suppose our current index is 2. Okay, so we're getting the letter, the second letter, and we're going to look here when we say, can 2 be divided by 5? No, it can't. What's left over? 2. So this is going to be 2. But let's say we were on the next row and we were doing 7. So we're on index now 7. So what we say is, can 7 be divided by 5? Yes, it can, once. And what's left over? Well, 2's left over. So again, that's going to be 2. So this is always going to be the same on the row that we're currently on, because we've only got 5 characters each time. That's always going to return the correct index. So we're comparing an individual letter, and a string, a word is a string, but that's really just a list of characters. That's why we can index that as a list. Okay, so let's try that and type in world, and that is correct. All of those are in the correct place and they're green. Now let's try it all in the wrong order, and that's orange, and then a mixture of things, and we get the right result. So that's our game logic for our guess sorted out. Now all we need to do is work out whether we've won the game, because if in the first instance we have got it right by some fluke, then we don't want to be adding more stuff. At that point we've won the game. So there's a couple of ways to do that, but here, before we get our copy of our grid, or after, it doesn't really matter. We're going to create a string which is our guess. So string guess equals, and now we need to get the row. We need to get the 5 letters of the current row. And so we can do that with grid, which we haven't copied yet. No, let's get the grid first. That makes more sense. Grid dot get range. The range is going to be the row start index, and the end is going to be the row end index plus 1. And we're going to then map those. Let's see if I can put that on the next line. And we're going to convert that just into the letter. So we're just getting the letter back. And then we're going to join those individual letters together to make a string. So if we print that now, you'll see that all that's happened is if we type in random stuff and hit enter, you'll see that printed out is the string of what we've just typed in. Okay. So what we can now do is we can work out whether we have a win condition before we do any emitting of anything. So we can say bool win is true if the guess word matches identically the word. So if we've guessed whatever the answer is, that is true and win is true, otherwise it's false. Okay, so then we can say if win do something, else do something else. Let's just format that a bit. Well, the else is going to be what we're doing already, and the win is going to be pretty much the same. Let's copy that up. Except if we've won, we don't need to increment the guess. But what we do need to do is change the status of our game to game status finished 1. Let's save that and refresh. Now, when we type in the correct answer and hit enter, we actually win. Now that's going to cause a problem because we're now able to delete here. So if we've won, what we want to do, I think, is get rid of the keyboard so that you can't do stuff like that, and put a message. Let's come back to our main screen and come up to where we've got the keyboard, and let's say if state status is playing, then show the keyboard. Else, if state status is finished, and remember, is finished is either of the conditions, whether it's won or lost, then let's put some text in which says, I don't know, game over, maybe. And that'll do for now. Although I'm going to make use of our other function, I'm going to put an elevated button in which has an on pressed, and that on pressed is going to get the context read our Wordle block, add event, restart game. And we're just going to have text here, play again. Okay, these texts can both be constants. and put a few commas in to sort the formatting out. Okay. So the real Wordle game doesn't have a restart. This is really just for us. And now if we look at our emulator, we can see that we've got play again. Now we're not handling that event, so let's come to our block, and on restart game, all we want to do is emit a new state, and the new state we want to emit is Wordle initial, so we're starting again. But we also want to load, we also want to start our on load game again, because that needs to happen. So after we've emitted that state, we'll then add a load game event to our state, and then that will restart for us. So let's try that. Let's do a hard reset. Type in world, which will give us a win condition. Game over, play again. Play again. We start again. Okay. That is essentially Wordle. But we're not finished there. We've got a few niceties to do. For example, it's a bit of a boring game with only one word. Plus the fact we can make this look a little bit better. While I'm not going to spend huge amounts of time, we are going to make it look a little bit better and a little bit more playability. Right, so let's start by getting more words sorted out. And in the lib folder, I'm going to create a new folder called data. And in there, I'm going to create a new file called data.dart. And the way Wordle works is there's actually a predefined list of words. And well, there's two predefined lists. There's one of the words that the game is going to use for you to try and guess or solve. And there's another list of words that are acceptable to be used as input. So on our emulator, we've put in the word whatever that is. In the real Wordle game, that would not be accepted. So we need to create those two lists. So I'm going to create a const list of string, which I'm going to call available words. And that is going to be the list of all the words we can use in the game. So let's put in world. I'm going to put in my name. Why not? You know, because we can. I'm going to put in favor and one more word, robot. Let's put that down. Now, obviously, you will need a lot more words than that, but that's beyond what we're doing here. You can find a word list somewhere and get out 5-letter words. That's not the big problem. The other list we need is a list of accepted words. And again, these are going to be words that you can type in. So obviously our available words are all going to be accepted words, because otherwise the whole system wouldn't work. But I'm going to handle that in a different way. I'm just going to put in some other words. Gloom, gamer, motto, and that'll do. I'm also going to put in, just for testing, 5 Fs, just so I can, just so the game allows me to put that in for now. We'll obviously take that out before it was released. Okay, so let's come back to our Wordle.block and let's come up to the onload game where we select the word. Now, we're going to do this in 2 different ways, and I will leave them both in the code and comment them out. The first way is we're just going to pick a random one, and that's going to be what we use for now. So I'm going to create an int called random. In fact, I won't. I'll call it index because that will help later on. and that's going to be a random number which we need to import from Dart Maths. Random dot next int, and the maximum is going to be the available words which we need to import dot length. Okay, so we're going to pick a number between 0 and the however long that is, the available words is, and then our word is going to be the available words at that index. And just for us testing and playing, I'm going to print that word to the console so that we know what word has been picked. Right, so let's refresh that. And oh, that's good coincidence. So it's picked my name. Fine. So let's give this a go. Let's pick the word world. Let's try world as our first guess. Enter. And we can see that we've got 2 characters that are valid and the rest are not. So let's try drain. Enter. Ooh, well, that's a good guess, you know. And then obviously we can work out the correct word from there. Not that names would actually be used in Wordle. And we've won. Okay, let's refresh. Now, the problem is we can also type in gibberish and it's accepted as a guess. We need to stop that. So let's come down to our submit guess. And we're already making a string of what our guess is. So we've already got a string. We can say if the accepted words contains our guess, except we're going to say if not. So if our accepted words doesn't really contain guess and our available words doesn't contain our guess. So if neither of those lists contain our guess, we're going to return. Okay. Now at this point, we want to return with an error message. Otherwise the user's not going to have any clue what's going on. And I put that in at the very beginning. We can emit our state, copy with error message, and we can put here not a valid word, or you can put whatever you want. Okay, let's save that. Now we need to do something with that error message. So let's come over to our main and come up to where our keyboard is there. And I'm going to put the message just above the keyboard. And I'm going to just put in here text state error message. And we'll style this now. So style text style font weight bold. Yeah, let's do that. Font weight dot bold, and I'm just trying to get this on the next line, and we'll also put in a colors.red. That will do, and then we have our keyboard directly under it. Now this blue line is telling us that can be a const because the style is fixed. Now that works well, and if we save that and refresh our app, we don't see the message, although it is being displayed on the screen. And that means this keyboard won't jump. When the message appears, it won't jump because there's already text string there. But by default, our error message is empty, so it's not displayed. So if we put in an unaccepted word and hit enter, we get our warning. Put an exclamation mark there. Excellent. Well, with our warning in place, what we don't want to do now is allow them to have another guess or submit anything really until they've hit the delete button. So let's come back to our block, and what we can also do is where we say, if letter is empty up the top here, so if state grid letter is empty, so that's one of our checks, we can say or state error message is not empty. Okay, let's stick it in curly brackets. Just I'll have to move the emulator so you can see it. So now if we hit enter, or if we hit refresh first, make sure the block is reloaded, put in an invalid word, we can't hit enter again, nothing works. So with the delete, whenever we delete a word, we can reset the error message. So on delete, whenever we copy with our delete, we can also set our error message to be blank at that point, because that's the only time there's going to be a non-valid word there. Yep. So hit delete, our error message goes, and we're free to try again. Okay, let's refresh that, get another word. Okay. It was just a fluke. It kept picking drag as the word. I wanted a different word. That's only because we've got so few words in there. Okay, so we got robot this time. Let's get that as a right answer. Enter. And I think we can improve our message here. So we've got game over. Let's put underneath game over a size box with a height of 10, and then under there another text which is going to be based on the state. So I'm going to put state game status is finished 1. So if we won, then our text is going to be you won in, and then state dot guess number +1 exclamation mark. Yeah. Otherwise we'll say you lost, the word was state word yeah, okay. Why am I getting an error here? Because there shouldn't be a bracket there. Should be a bracket at the end here. Okay. This size box can be a const. Let's try that. So I won in 1. I did. Let's refresh and let's completely lose. So to do that, I'm just going to type in a lot of F's, which is one of the reasons I put F's as a valid word, just so we can test like this. And we're not handling that. Okay, so we've got to the end and we're not dealing with that. I must admit, I thought put that in. Right, back to our block and come down to our submit guess, and where we've got our omitting, so we're saying if we win we're going to finish the game. Well, there's going to be another condition that we also finish the game, and that is going to be if the grid, the last box in the grid letter is not empty, or we've won, then the game ends. But the game status might be different. So it doesn't, that's not always a win. It's a win if we've set win to true. Otherwise it's a game status finished lost. Okay, let's save that, refresh, and very quickly run this again. There we go. Game over. You lost. The word was drag. Play again. The word is world this time, so let's put a couple of false entries in. We haven't checked. Let's put in one of our valid words just to make sure that works. Gamer. Yep, that works. And then we'll get the correct word. Done it. We've won in 4. Okay. Now I said there was 2 ways of picking our random word, and the way Wordle actually does it is it works out the number of days since the game started and just picks the next index. So let's comment this row out and let's do it that way. So int index equals date time now. Find the difference with date time pass, and we've got to put a date in. So let's put today's date, which is 2022/06. You need to make sure that the day, the month and the day are double digits. The hyphens are optional. In days. And that should also work. So if we look at our data, we should get world as our word when we save it. Sorry, that should be a string. So let's just formatted that and put spaces in. Need to put that as a string. So let's save that and refresh. And we have a problem because the value, why did I think it's the 6? I don't know why I thought it's the 6. It's not the 6, it's the 12. I'm in the future. Okay, let's just do that. So the word is world. And if the game started yesterday, then the word should be drag, which it is. And then we should have favor and robot as we go back 2 more days. So let's go back 2 more days. Favor, yeah, and then robot. Okay. Now if we go back 1 more day, we're going to run into an error here. And it's because we haven't got an index anymore. We haven't got the number of days is longer than the available length. So to fix that, what we're going to do is we're going to put this on the second line so we can see. What I'm going to do is just modulus that with the available words dot length, which means it'll basically do the same thing that we did previously, and it'll take the remainder and it will wrap around and it will start our list again. So if we save that now and refresh, we should be back at our first word, which is world, and we are. So that's the second way of doing it. For now, I'm going to revert back to the random way because it's easier for testing. It does mean there will be a little variation, although with the number of words we've got, not a great variation. Right, all that's left now is a little bit of tidy up. So we're not going to be adding, I don't think, any more features to this. That is the game. If you wanted to leave it here and go and decorate it however you want, you could, but I am going to go on a little bit further and just make it look a little bit better. So most of this is going to be styling and putting a little bit of animation in. Okay, so while we're here, let's just come to game over and put a style in. Well, let's come to game over and put a style in. And the style is going to be text style, font weight bold. It's on multiple lines, and font size 20. I think that'd be okay. Let's just get our correct word in. Let's get our windscreen up. Yeah, that looks a little bit better. The next thing I want to do is get the letters in our boxes looking a little bit bigger. So let's come to where we put that in and add a style there as well. Text style. And let's see if we can get the font size to 40. Maybe too big. 35. Still too big. 30. Okay. And I think I want the letters to be in uppercase, so I'm just going to add 2 uppercase there. Yeah, okay, and we'll stick a const on the end of that. And then refreshing the game. For our keyboard, I think I want those in uppercase as well. So let's just come down to the letter and again put 2 uppercase there. And looking at the keyboard, this enter and delete button, don't like those. So let's come into our build and let's say, I want a logo here. So I'm going to create a widget called key character. Yeah, okay. And that by default is going to equal text letter to uppercase, uppercase. And then I'm going to say if letter equals ent, then I'm going to change the key character letter to be an icon, icons dot, hang on, I've done this before, subdirectory arrow left, yes, that's the one, and make that a bit smaller, probably 15, and its key character equals, and then at the bottom, instead of putting the child as text there, the child is going to be the key character. Let's save that. Okay, that looks okay. And then we just do the same with the delete. Else if letter equals del, then key character, it's going to copy this line, and the character is going to be west. That's fine for backspace. You could also change the size. You could also put here and make the width of those two a bit bigger if you wanted. I'm going to leave it as is. Okay, so then we type in our word, enter, not a valid word, oh yeah. Let's try world, which happens to be the right answer. And I want to do something with this. I want to animate it a little bit. And this is going to be, and there's a couple of ways of doing it. Where's the builder? The quickest way of doing it would be to change this from a container to an animated container and give it a duration of 500 milliseconds. So if we type in a word now, you can see that it animates between one and the other. However, I want to do it a little bit more interestingly. I want the letter to flip around, and that's going to be a little tricky. Yes, so what we have to do is undo what I've just done. So put this back to a container. And I'm going to instead wrap this container in an animated switcher. Now an animated switcher also takes a duration. And I'm just going to put seconds 2 for now. That's way too much, but from a point of view of actually seeing what happens, we'll have a longer thing. Okay, so I'm going to save that. And what we need now is to basically swap our container. So I'm going to take a copy of the container, I think, and say here, if, sorry, not if, it isn't if, but if status, box status is blank, show that container. Otherwise, come down and paste in the same container. So at the moment, we've got the same container twice. And in fact, it needs to be blank or box status is answered. You're going to have to forgive me here because I'm thinking on my feet. We'll see if we can make this work. Okay, so let's save that and just make sure we haven't got any horrendous errors. Refresh. Load of Fs, and it should just switch between the two. Okay, which it has, although you can't really tell. So now we can come here and we can look at this and we can make a few changes. First of all, if the container is blank, then the color is always going to be black. So let's set that to colors dot white, white. And the text, I'm going to change the text color here as well, because what I want to do, oops, in the style, what I want to do is, if it's got a colored background, I want it to have white text. So I'm going to put here, if I can get it into the right place, font size 30, colors black. Okay, and then if we've got the word in there, then the color is going to be whatever color we get, and the text color is going to be colors dot white. Okay, that seems to have worked already. What's our world? For testing purposes, I'm just going to come up to the block and I'm going to, in our submit guess, I'm just going to comment out this bit that tests to make sure we've got a valid word. Just for now, it's just so it's easier to be able to type in random characters without thinking too much, because I want to see the different words. We'll put that back in a moment. Okay, so we've got that, but the animation isn't what I want. So what we need to do is create, in our animated switcher, we need to make a transition builder. And I'm going to do this as a separate function, which I'm going to call transition builder. So here above, get color, let's create a widget which is a transition builder. This will take a widget which will be passed into us from our flip animation, from our animated switcher. It'll also take the animation. Animation double animation, and we're going to return an animated builder. Okay, let's just check that's happy up there. It is. Okay, so the builder is going to take a context and a widget. Let's have a think about this now. So the right, we need to know the rotation. So we need to change the animation. So I'm going to call this the rotation, and that's going to tween between begin the circumference of a circle pi, and it's going to end at 0, 0. Pi we should be able to import from Dart Math, I'm pretty sure. Remove unused variable pi. Why is that not imported? Import Dart Math. Okay, don't know why that wasn't importing. And we need to animate that based on the animation that has been passed in. Then we need to return a transform, and the transform is going to be matrix for our rotation on the x-axis. And let's just do the animation value for a second. Animation value, see what we get. Right, the child of that is going to be the widget. And let's see what we've got for a second. If I refresh that, we're blank. It's because we need to put a child of the widget in here as well. Refresh. Yeah, that's not quite what I want. Let's change the alignment here to alignment center. And okay, sorry, I'm trying to do my maths now in my head. Oh, it's because I'm putting in the wrong animation there. We've done the calculations. It's the rotation we want, not the animation. Right, let's refresh that. It's still not quite what we want. And I think it might be. Let's try giving these containers a key. Const key front. Key front. Get that right. And this one is the back. Let me save that. That's better. Sort of. Let me refresh. Okay, that's sort of working. We can sort of see the other one under it. So we need to work out if it's under, if the back one is under. Let's try this. Under equals const key back not equal widget dot key. What's that complaining about? Not null. Yeah, okay, I know I've given it a constant. And then final value equals, if it is under, then let's take the minimum value of the rotation value or pi divided by 2. Otherwise, we'll just take the rotation dot value. Yeah, and then use that value there. I think that's going to work. Let's try. Okay, that works. So let me see if I can explain what's happening. We've got our rotation, which is a number between pi and 0. So as our animation progresses, as our animation is a double, it progresses from 0 all the way up to 1 over the period of 2 seconds that we specified above. So over that period, it goes from 3.14 to 0. So that's that number, which is put into the animated builder. And then what we're doing is we're saying if the current widget, because the widget flips halfway sort of through the animation as the animated switcher, that's the word, as the animated switcher switches. If the current widget does not equal our back one, okay, then we know that the back one is underneath, but we shouldn't be able to see it. And so the value is the rotation value, i.e. this number that's been calculated, or pi divided by 2. So pi divided by 2 obviously makes it so the rotation is halfway round, so we're looking at it edge on, so you can't see it. Otherwise, the rotation value, and then we rotate it round. Now there is another issue there that I've noticed, is that it appears straight away, and I think we can solve that one by flipping our stack here. So if we come up back to our animated switcher and put a layout builder, that takes a widget and a list, I think, yeah, list of the widgets. And what we can do is we can put it all into a stack. So we're going to return a stack, and the children are going to be the widget, which is probably giving us a null error, is it? Yeah. So we'll just say that exists. And our list. Okay, let's refresh that and try hitting our Fs. Hey, that's what we want. Okay, what's our word? Favor. So F-A-V, I'll spell it wrong, so we hasn't quite got it. Yeah, that's fine. And then favor. Perfect. We can make this a little bit better. We can add some curves to this. Switching curves. Let's just do an ease in curve. Curves dot ease in back, because we're going 2 ways here. Let's try that. Oh, and of course we need to put a curve in for the other element. So that's the switched out. It's the thing we're switching out of view, and that needs to be the same curve but flipped, so that both the curves are identical. Then let's try that. Yeah. Okay, it looks a bit janky because it's so slow. Let's change the time to 400 milliseconds. Refresh that. And Yeah, I think that will do. What's the word? Robot. And that, my friends, is Wordle. I think that's everything we need to do. Whoa, okay, lesson learned for me there. Practice what I'm going to do before I try and do it, just to make sure it all works properly. I hope you've enjoyed. I hope you've learned something. If you have, don't forget to leave us a like and subscribe for more. And we'll be back with another project soon. Until then, folks, take care. We'll see you later. Bye for now.